So very good morning and hearty welcome all distinguished speakers and allied participants to today's session. Sivyamut sir, Jaya ma'am, Ruben sir, Satish Kumar sir and Rikukan sir and dear participants, welcome you all to the third day of our session of series of webinar on Indian seismic codes. Today, Dr. KP Jaya will be giving you an outline on the impact of seismic code provisions on seismic design and detailing of RC buildings. Kind request to all the participants to listen all the lectures as it is a rare opportunity for all of you to listen to the eminent speakers who were involved in the drafting of Indian seismic codes. The draft code is prepared by Dr. Sivyamurthy sir and Dr. Sudhir K. Jain. Now, I request Ms. Hemamati, Associate Professor of Department of Civil Engineering, to give a brief introduction about her guide and mentor, Dr. KP Jaya. Once again, welcome you all. Over to you, Hema.
Good morning to one and all. A warm welcome to our eminent resource person, Zoom participants, YouTube participants, and my dear fellow colleagues. I am overwhelmed and privileged to introduce the speaker of the day, Dr. KP Jaya ma'am. Dr. KP Jaya completed her BTech Civil Engineering from Kerala University in the year 1988 and MTech from Structural Engineering from the same university in the year 1992. She holds university rank in both her UG and PG programs. She completed her PhD from IIT Madras in the year 2000. She started her career as fellow scientist at SCRC in 2000 and served for 1 year. Then as Senior Project Officer in Structural Engineering Division, IIT Madras for 1 year. She joined Anna University in the year 2003 and currently she is a professor in Structural Engineering Division, Anna University. Added to her credential, she has been given additional responsibility as Director Center for Research, Anna University from the year 2018. Her research interest includes, but not limited to, structural dynamics, earthquake engineering, reinforced concrete structures, precast structures, vibration control, wind engineering, and soil structure interaction. She is a panel member of CD39 Earthquake Engineering course of BIS New Delhi and panel member of CED2 Cement and Concrete course IS456 of BIS New Delhi. Also, she was a chairperson of Indian Concrete Institute, Chennai chapter from the year 2014 to 2018. She is an independent director, Tamil Nadu Police Housing Corporation from the year 2016 till date. She is also a panel member for preparation of Precast Handbook and Indian Concrete Institute Initiative. She was a technical committee member for the preparation of Tamil Nadu government document Guidelines for Reconstruction of Houses Affected by Tsunami in Tamil Nadu. She is an associate editor for Journal of Applied and Engineering Sciences, published by Anna University from the year 2014 till date. Also, she served as Executive Director, Building Technology Center, Anna University from the year 2010 to 13. She has received Active Consultant Award 2014, Anna University, Chennai, during the Teachers' Day function from our then President Dr. APJ Abdul Kalam. And as Chairperson of ICI, she has received Special Award for Best Performance in the year 2016 from ICI Headquarters. She is an active life member for many of the professional societies like Indian Concrete Institute, Indian Society of Earthquake Technology, Indian Society of Wind Engineering, Institution of Engineers India, Indian Society for Technical Education, and Association of Consulting Engineers. Under her guidance, 10 scholars have completed their doctoral degree and 10 members are currently pursuing their research. She has published more than 50 research papers in international and national journals with H-Index 12. We are very fortunate to have such an eminent person today to enlighten us on impact of seismic code provision of seismic design and detailing of RC building. Thank you for accepting our invitation, ma'am. Without any further delay, I request ma'am to take over the session. Thank you one and all.
Now we can start the session, Jaya ma'am.
Thank you. Thank you for the introduction, but it was too little long. Thank you. So before starting the session, good morning to all the panel members, Professor Murthy, Professor Rupan, Professor Satish Kumar, Professor Raghukant, and Professor Binu Sukumar. Professor Binu, a special thanks to you for giving me this opportunity to address this good audience. And I take this opportunity to congratulate you for arranging this type of seminars.
Okay, thank you, ma'am.
Professor Murthy and Professor Rupen, we are listening to you for the last 2 days. It was very much knowledge sharing. Thank you to Professor Rupen as well as Professor Murthy. And I have taken your one of the document which you have prepared by a group of people, by you, Murthy sir, Rupen, and my student Vijay Narayan and all, for the presentation in this particular webinar. Thank you all in advance. And my duty is to share the knowledge related to IS13920. Let us start with the slide. It's a dynamic earth. Yes, of course, our earth is always dynamic. We can't compare with anything else. It's always dynamic like young children. Sometimes the dynamism will turn out to be furious actions. The Mother Earth will impart some furious actions in the form of earthquake, or the after effects, a tsunami, and sometimes in the form of cyclones. What is the net effect of all those things? The people will left out as homeless. And you can see the debris in front of the child and this lady. And the child is looking at what is the next, what is the future. So it's our responsibility. It's the learned person's responsibility to take care of this type of homeless people. And we are responsible enough to make good structures. It should not be fail and kill the people. With this small introduction, let me just show one small slide. The next 1 minute. Yeah. So in South India, many of the people wouldn't have experienced the severity of earthquake. Just watch this video. 1 minute. This is a level of shaking the building is experiencing. What will left out with the buildings? The building would have undergone different types of damages and failures. See, let us see some of the past experience and failures of the building which has suffered during various severe earthquakes. In Bhuj earthquake, which has happened in 2001. Just see this picture. This is the failure, shear failure of the column. This is due to the improper confinement of the longitudinal reinforcement. Why the column is failing under shear or under flexure? The answer to this is explained with further slides. I'll come back to that. Here, please see the buckling of the longitudinal reinforcement. This wouldn't have erased if you have provided sufficient lateral ties to confine the longitudinal reinforcement and the concrete within that. This shows the lack of confinement and the failure of which lead to the failure of the column. Next, see this picture. This is from the 1994 Northridge earthquake. This is what is called the short column effect. You can see here the column, the length is very short. These columns will be experiencing, if you take two columns with a longer length and another one is short length, both will be experiencing same amount of moment at the top and bottom. And unfortunately, being the shorter length of this column will lead to the higher amount of shear at the top and bottom of the column, which will lead to the failure of the columns in the shape of X-shaped crack. This can be avoided by providing sufficient length for the columns. We should avoid the short column introduction of short column in structures. And this is the failure of open ground story. Due to the open ground story effect, this picture is very, very common to everyone. many of would have been seen in all the presentations by Professor Murthy as well as Rupan. And there is a common misunderstanding about among the structural engineers about the masonry walls. We always treat the masonry as a non-structural element. That is a false belief. You just see, yesterday also we have seen this picture. This infill will contribute as a compressive strut and offer additional resistance as well as additional stiffness to the floor. So this additional stiffness will leave out the bottom ground story as a soft story element. You can see here, this picture shows this curve. You just see this is the unreinforced masonry infill walls in all stories. If you are providing the same type of infill in all stories, your curve will be going like this. And if you provide the frames infills in all stories, no URM. This is a bare frame. This will be showing you. Just see this picture. When you introduce some open ground story effect, this will leave out a different shape of sudden change in the mode shape of the phenomenon of the buildings. So this will lead to the softness, which will lead the softness in the bottom ground story. And this should be avoided at any cost. You can see this one, this is the failure of the building due to the weak column and strong beam effect. You can see this, the column dimensions are very, very slender compared to the beam dimension. This has to be totally avoided in the construction. The provisions are very much given in 13920. And this is the failure of the core diaphragm interaction. This is due to the improper connection between the core and the diaphragm surrounded by that. It is almost similar to the spinal shear. The core can be treated as the spinal cord in our body. This at the end of the day, after the earthquake, it is left out as the spinal cord is standing, all other part of the body has come down. What is the purpose of this? So the proper connection has to be incorporated in between the core as well as the diaphragm surrounded by that. And there is a belief that if we can introduce shear wall in any of the building, that will improve the performance of the structure. That is not exactly true. If we want to get a proper performance of the structure, we should properly detail the shear wall. Without proper detailing of the shear wall, we cannot expect the better performance from the shear wall back to us. Whatever we are giving, that only we will get back. Why these failures? That is the first question we should ask. Till 2000 or 1994, Latur earthquake, people were concentrating only on designing the structure with gravity load. Gravity load is very clean and simple. If a structure is loaded with gravity loading like this, that will give out the deformations like this, and we can gauge that the bending moment diagram exactly like this. There is no issue when the structure is loaded only with gravity loading. We can define where the tensile stresses comes. For that particular tensile stresses, we can give appropriate reinforcement and do the design, carry out the design. But in case of lateral loading, when the frame is subjected to lateral loading, and not only lateral loading, it's a reversal lateral loading, it will undergo to and fro motions and leave out. It's during the reversal of the loading, the nature of the stresses in the members and the sections will be varying. This will leave out. It's a very major problem and leave out. And we have to appropriately detail the reinforcement to take care of such introduction of tensile stresses as well as the compressive stresses. So even though in 1935 onwards, military engineering people have given us proper provisions to design and construct buildings earthquake resistance, we the engineers were least bothered about incorporating all those provisions. But when we experienced the damages during Latur earthquake as well as Bhuj earthquake, the researchers started thinking about how can we safeguard our structures. So there comes a lot of revisions in our codal provisions. So you can see this performance of the columns during the lateral, due to this lateral loading, you can see the failure of the columns. Mainly, the affected elements will be columns due to the lateral reversal lateral loading. You can see here the shear failure in the columns when the shaking is in this direction and say is in this direction, the column top as well as column bottom will be experiencing cracking in this direction. When the load reverses, the direction of the crack also will be getting reversed. And once number of shaking, to and fro shaking will leave out the spalling of the concrete and the development of the X-shaped crack at the top as well as bottom of the column. This is what I told. This is the occurrence of the shear failures in these columns. Mostly when you look at the failure of the columns, you can experience the cracking and spalling of the concrete at the top as well as the bottom of the columns. This is the shape of cracks developed due to shear, and you can see here during bending and as well as flexural action of the columns will be experiencing the cracks very much perpendicular to the axis of bending. So this is the failures occurring in the columns due to the lateral reversal lateral loading. There comes. This is the reason for all these major failures we are experiencing. So Professor Paule as well as Priestley together, they have commented that based on, it's actually all the earthquakes we can treat it as what I can say, experimental investigations. We are doing experiments, generally we are doing experiments in the laboratory, and we can treat the earthquake as a natural laboratory. Our mother earth is the lab, and whatever be the mark left out as the experimental investigations. And based on the previous earthquake investigations and whatever be the left out, very much told by Paule and Priestley that not only the lack of strength result in the failure of the structures. If the structure could survive, the structure could survive if we could maintain the lower strength and allow the deformation in the system. So that's what it is. We can, without excessive degradation, if we permit to behave in an inelastic deformation pattern, we can allow the structure to survive any earthquake. This is what is called the ductility. Now comes to the point like, what is ductility? Ductility is one of the major important factors that is affecting the performance of the buildings. You can see here, this is the elastic range. Beyond the elastic range, if we allow the concrete structures to behave beyond the elastic range and go to the inelastic range, allow to undergo maximum deformations without losing its load carrying capacity, we can make the structure as very good with a very good performance. So this, what is ductility, is the ability of the reinforced concrete members to undergo considerable deflection prior to failure without losing its load carrying capacity. Strength should be maintained that level, maximum level, and we should allow the structure to undergo maximum deformation. What are the provisions we can given to the building to perform in this fashion? That is very important. So what is the importance of ductility? The ductility member can elongate more and absorb more energy. We know very much, all the engineers know, the area under this low deflection curve is the energy absorbed by the system. If we can increase the area, if we can make provisions to increase the area under low deflection curve, automatically it will dissipate more energy or absorb more energy, and which will avoid sudden failure and provide sufficient warning. You can see this is a brittle material. It will fail immediately once it achieves the maximum force level. Sudden brittle failure happens. The elongation is very, very small. And if we allow, we can give provisions to behave in a ductile manner, we can achieve a big, larger deformation without losing the strength, and we can dissipate or absorb more energy. And all these pictures I have taken from Professor Mutisa's document which is the document I'll tell at the end of my presentations. So this picture shows if you are providing a poor ductility, the structure will fail with a lower strength, with a lower deformation. And if you provide sufficient medium ductility, it will provide sufficient strength as well as the deformability. And if we can provide a good ductility, the code 13920 is discussing about how we can impart good ductility in our system. So if we can provide good ductility, that will give us better performance back. That's what I told initially. What we give, that will get it back. So comes to the principles of ductile design. How we can incorporate all these ductile pattern into the system. We can incorporate ductility, redundancy and overstrength to the system. Thereby we can bring down from this elastic type of performance of the structure. If we provide ductility and it will start performing in an elastic manner, we can bring down the demand of force from this peak level to this level. And if we can incorporate a redundancy to some extent, that will bring down further down. What will be the demand of the load will further come down. By incorporating overstrength further down, we can bring down the design force or the demand of the system. So that has been incorporated in the code, the introduction of response reduction factor. Then with this, we can design the structure with a lesser lateral load. And what are the principles of ductile design? It will prevent failure due to shear and bond. And there is a necessity to confine the concrete with the use of lateral ties and detail and confine the potential plastic hinge regions. Yesterday, Professor Rupan was discussing about the occurrence of plastic hinges. It has to start, we should avoid plastic hinge occurrence at the roof level and all those things he was explaining. So we have to confine the concrete or confine the area where the potential plastic hinge can occur, and adopt the methodology strong column, weak beam, and detailing of the structural members and the joints appropriately, and under reinforced design of flexural members, detailing of ductility to incorporate proper anchorage, proper hooks and splices. Those areas where and all we are doing these additional features, we have to provide appropriate detailing. So these are the code which provide us the guidance for appropriate ductile detailing and design of. Initially, the title before in 1983 code, the codal title was ductile detailing. The design has been introduced now in 2016 edition. What is the scope of 13920? It will talk on the lateral load resisting structural system of RC structures composed of RC moment resisting frame with unreinforced masonry infill walls, as well as with RC structural walls and the features related to RC structural walls. This is the scope of 13920. And general material specification what we suggested by this codal provisions, that minimum concrete grade should be M20. And if the height of the building is more than 15 meters in zones 3, 4, and 5, we should minimum M25 concrete has to be adopted for the construction of the buildings. And maximum permissible factored axial compressive stress is limited to 0.08 FCK. Earlier it was till 0.1 we were allowing, now it's 0.08 FCK. Steel strength, Fe 415 or lesser is much better because that will give you more ductility. And if we want to go a little higher, then we have to adopt Fe 500 or Fe 550. That to TMT bars, the elongation limit as 14.5%. Now comes to the detailing part of the beams, how we can make our beam elements as a ductile one. Now you look at the modes of failure. We always design or come out with any solution from the mode of failure. First, we should study the failure. We should give provisions to safeguard the structure from that particular failure. You look at this, the beam can undergo flexural failure as well as the shear failure. When you look at the nature of failure, the flexural failure will be ductile and the shear failure will be brittle. But we always prefer to go with the ductile type of failure. We always try to avoid this shear type of failure as well as the brittle failure. Now comes the ductility consideration for the flexural members. We should avoid shear failure. Means we should strength should be much higher than the flexural strength of the member. If it is so, we can avoid shear failure. And design the members as under reinforced section. The under reinforced section will give more ductility to the system. Avoid bond and anchorage failure. Use closely spaced stirrups and splicing of the bars desired at sections of minimum tension. We should make sure that we are splicing the bars with minimum at sections with minimum tension. Detailing at the area of splicing is very important. Look at the provisions given by the code as per the clause 6.2.3. It says that we should have minimum diameter of the bar as 8 mm and we should continue with the minimum 2 bars at top and bottom of the beam. And look at this provision. So clause 6.2.3 says that the longitudinal steel at bottom face of the beam, you look at this junction at the column beam interface area, at least when you look at the top steel, you know that the steel requirement for the holding moment will be higher than the steel requirement at the bottom of the beam at this particular junction. There it is mandatory that the area of the steel at bottom should be at least 50% of the area requirement at the top, because the reversal of the stresses can come, and then we need to safeguard any type of stress accumulation at the joint region. So this is the mandatory requirement provided as per suggested in the code as per clause 6.2.3. At this joint, at this junction, we should provide at least 50% of the top reinforcement as the bottom reinforcement. Now, and this longitudinal reinforcement cannot be beyond some limit, as well as, even though we are telling it has to be designed as a under reinforced section, there should be some limitation over the lower reinforcement that has been given in the code as rho minimum as 0.24 ρ by Fy. And similarly, we cannot go beyond also. The maximum reinforcement percentage is 2.5. So that also has been given as per the codal provision in order to confine the concrete appropriately with what I can say, it should provide ductility, but it should not be brittle, and it sufficiently should provide ductile detailing as well as the ductile type of failure. And another clause of 6.2.4 is mentioning about throughout. Now it clearly says that area of the steel at any end during along the longitudinal length of the beam at top and bottom, the steel should be, area of the steel should be 1/4 of the steel requirement at the top of the beam at the beam column junction. That is very, very important. Like at any place along the length of the beam, you can see here the longitudinal steel in beams at any section on top or bottom face should be at least 1/4 of the longitudinal steel provided at the top of the beam at the junction. This is very much important to maintain the integrity throughout the length of the beam, because we are providing a lot of steel at the junction, the beam column junction at left as well as right. What about the reinforcement detailing at the middle portion of the beam? There we have to give attention, and we need to provide at least 1/4 of the steel requirement at the top of the beam has to be maintained throughout the length of the beam. And proper anchoring. We are talking about the reinforcement coming from this at the top and bottom of the beam, and how it has to be anchored. If this is showing the exterior beam column connection, the anchorage length should be the development length plus the 10 times diameter of the bar. As per the gravity load design, we are providing only development length. At every connection, we are anchoring to a length of what is required as development length. But in case of structure subject to lateral loading, we are giving additional 10 times diameter of the bar to provide proper anchorage of the reinforcement to the concrete area. And the longitudinal reinforcement, sometimes we need to splice. What are the methods adopted and permissible as per the caudal provision is the lap spacing, splicing, sorry, spelling mistake, splicing, as well as splicing with mechanical couplers also permitted, and welded splicers also permitted. What are the provisions given for the lap splicing? Lap splicing is the bar should be spliced within, should not be spliced within a joint. We can have a joint in beam column joint. Wherever the connections comes, we are not supposed to splice the bar within the joint, and within the 2D from the joint face. You can see here within this area you are not supposed to, and we should make sure that the within the quarter length of member also. So we should avoid this joint region, because there we have a lot of shear stresses coming into joint region. Here also it is subjected to higher level of shear stresses. And here you can see this quarter length also we should avoid splicing the reinforcements. And more than 50% of the bar should not be spliced at any sections, because at least minimum 50% of the bar should be there to maintain the compatibility between the steel and concrete. And you can see here, wherever we are providing the lapping, there we should provide closely spaced stirrups. So we should provide confinement, reinforcement at that particular area. So that's what it is mentioned here. And mechanical splicers also, couplers also permitted when we need to couple the splice the bars. So the couplers should conform with IS16172. It should be capable of developing specified tensile strength. Tensile strength, whatever is there, whatever is supposed to get developed within the longitudinal bars has to be developed by the splice, this mechanical coupler also. It's permitted within a distance 2D from the joint face. It is permitted at a distance of 2D from the joint face also. And the spacing of adjacent long bars shall be based on the outer dimension of the couplers. When we think about two or three bars, if you are planning for around 4 bars at the bottom face of the beam, the distance between two longitudinal bars has to be decided based on the outer dimension of the couplers, because we have to keep sufficient spacing to accommodate the concrete aggregates into the space in between the reinforcements also. And the welded splice is also permitted within a distance of 2D from the joint face, and more than 15% of the bar should not be spliced at any sections. These are the clauses and provisions given for splicing the longitudinal reinforcement within the beam region. And comes to the, so this is why we were talking about the longitudinal reinforcement. This longitudinal reinforcement has to be bundled together and should be protected, as well as the interior core concrete also should be confined only with the introduction of transverse reinforcement. In the case of transverse reinforcement, the provision minimum link diameter has been given as 8 mm, and we can use either single bar U bar. Single bar means it can bend, start bending from here and go through this way and come back. This is the single bar tie, and we can use U bar tie also. Sometimes due to the practical difficulties in the site, sometimes we may have to adopt on U bar with a cross tie. And this hooks with 135-degree is extension of 6D. This extension is 6D is mandatory, and the angle of bending of this hook should be 135 degree as mentioned here. And the transverse reinforcement, how it has been spaced, it has been very much specified like in the near the joint region where the shear force is shear demand is more. There we have to provide closely spaced stirrups, and wherever the intermediate area we can provide the links with as per the design. And shear capacity, when we are thinking about the beam, now at this joint, beam column joint, the shear demand will be more. And what is the capacity we have to arrive at? It is based on larger of the factor shear force as per the linear analysis, as per the analysis what we are getting, and factor shear force plus the equilibrium shear force developed due to the formation of the plastic. You can see here, when the beam is loaded like this, and moment is getting developed at both the ends. This moment will create additional shear into the system. You can see here we are putting a, what I can say, factor as 1.4, and this is the length of the beam, and this is due to axial dead load plus live gravity load, and we should incorporate the shear developed due to this moment generated out of lateral load also should be taken into account. This shows the when the say from towards the right, from the left, the building is saying towards the right, the moment developed, the nature of moment developed at the joints are like this. This has to be added along with the normal gravity load shear force. And the larger of that we have to consider and design for that. Now comes to, okay, so this is the shear capacity. Shear capacity of the beam should be always much higher than the demand coming from the capacity should be always more than the demand. Now I'm planning to talk about the column provisions, ductile consideration for the flexible columns. You can see here, like avoid long columns as well as avoid short columns, and spiral confined columns. We are always sure that the spirally confined columns are giving a much better performance and will be more ductile than the tight columns. And we should adopt strong column and weak beam philosophy. And we need to provide closely spaced ties or spirals to provide more ductility to the system, and splicing of the bars desired at mid height of the columns. In this case, in the case of columns, the splicing can be permitted at the column where the bending moment is always zero, and shear force, design shear force need to be arrived at based on the moment as well as gravity load shear. The dimensions restrictions is like that. Minimum dimensions of the column should be 20 times the diameter of the largest longitudinal bar, or 300 mm, whichever is more, has to be adopted as the minimum dimension. We have to adopt as per new UBC code also, fire consideration also we have to consider, and the minimum cross-sectional aspect ratio between the length to breadth of the column in plan dimension should be maintained as 0.45. This is the provisions given for providing a sufficient strength criteria. To satisfy the strength criteria, we should follow this minimum dimensional requirement. Comes to the stage of strong column with me. So we should always adopt this clause A, not to adopt this one. See, this strong beam and weak column, as per the capacity design, we should adopt the methodology like a general philosophy. If one slab fails, only the elements as well as people in that particular slab will fail. If one beam fails, the subsequent or consecutive slabs will fail. And if one column fails, that will lead to the failure of the structure. So better we should provide, based on the capacity based design theory, we should provide strong column and weak beam. I'll rename as strong column and beam, not a weak beam. We need not design as a beam. Sufficient strength is required for the beam as well as column, but the column should be much stronger than the beam. That should be the terminology. For that, accommodating that particular clause, the code has given a provision that some of the column moments, if you can see here, this you can see in this joint. This is the joint from where the columns are meeting as well as the beam also meeting. And either end of the joint, the beam end moments are acting, and top and bottom of the joint also the column moments are acting. So the sum of the column moments, so sum of the column moments should be more than 1.4 times the sum of the beam moments. That is the general provisions given by the code to satisfy the condition as strong column and weak beam. So why? What is the necessity of the confined lateral ties into the system? Now we were talking about the strong column weak beam. We are finished of that. If we can provide the columns much bigger than the beam, we can achieve this condition of sum of column moments is should be more than beam moments. That is a clear fact. Now comes to the ductility part. How we can make the columns more ductile? That for that we need to confine the concrete. The confinement of the concrete. What you look at this picture, when we provide a lateral ties like this, and the area of the concrete confined within this longitudinal bar as well as this lateral ties will get confined. Look at this picture. If the spacing, the leg of the stirrup is much more, what will happen? The area in which this plain area is unconfined concrete. This shaded portion is the confined concrete. If this, we have to maintain the length of the stirrups within 300 mm. That is also mentioned. It's a clause given in the system. So while confining the concrete within that lateral ties as well as longitudinal reinforcement, that will give more ductility as to the total system. Less the spacing of the lateral ties, more the confinement of the concrete, more the confinement of the concrete, which will yield the more ductility to the system. You can see here, this is the graph for the stress strain graph for the unconfined concrete. This is the graph for the confined concrete. When we are confining the concrete, that will give a more stress level as well as a more deformation into the system. This is the stress strain curve for the concrete within the structure, and this shows the stress strain curve of the steel used in the reinforced concrete structures. So once we are confining, if we are using a mild steel, it will give more ductility, and almost whatever be the required stress level also it will maintain. If for the high strength steel, it will take a peak, and the deformation capacity is limited compared to that of the mild steel. That's why we are always insisting on that. You limit the use of steel to the range of Fe 415 and below. And now comes the ductility provisions for columns. Again, I am talking about the transverse reinforcement. The minimum diameter of the link should be 8 mm. If the main reinforcement diameter is less than 32 mm, if the main reinforcement diameter is more than 32 mm, we need to use 10 mm bars. The maximum spacing should not be more than 300 mm. That's what I was telling here. If the spacing between the lateral ties is more than 300 mm, the unconfined concrete area will be more compared to a closely spaced stirrup reinforcement. So comes to this. In any case, one side of the links exceed 300 mm. Cross ties need to be provided. The cross ties need to be, once we provide cross ties, we will get more confined concrete area. That is the need. You can see here, this is the provision given in the code. If this is the single tie, and this is the tie with cross tie, as the length of the tie in the one side is more than 300 mm. We have to provide that. In case if the leg length, unsupported length of the tie is more than 300 in both the direction, then we have to provide 2 ties on either side. Now we are mentioning that we need to provide the bend as 135 degree. Why 135 degree? The hook with 135 degree with extension of 60. That is the provision we are getting. We are always telling. Why 135? Why not 90 degree? You just see this picture. You can see here, this is also a tie. Initially, it has given only 90 degree bend. When the longitudinal reinforcement started buckling, the 90 degree bended bars will open up and give way for the longitudinal bars to buckle, and the inside concrete area will become unconfined. That will also start falling. So generally, the practicing engineers, whatever we are telling, they will not accept the condition that the 135 degree bending is always a problem in the site. The bar benders are not at all supporting us. We are finding it's quite difficult to, what I can say, to incorporate this thought, the 135 degree bend in our lateral ties. But we cannot accept that statement. We just to see, watch this video that will show how we can manufacture these cross ties with 135 degree in the site itself. Just for a small moment. Just see, this can be manufactured in the factory and purchase it, bring to the site and incorporate it in the constructions. You can see here, then and whatever be the shape, whatever be the length, we will be able to manufacture in the factory and bring to the site. You just see, CNC machine, whatever be the shape you want. We need not depend upon the bar benders on the site. So this is a small video I thought of sharing with the youngsters. Whenever you are going to the site, make sure that the 135 degree bend is incorporating in the stirrups. Without 135 degree bend of stirrups, the purpose of providing the stirrups will not met with. So this is just see the failure of the column with lack of stirrups. You can see this is a picture which I have taken from the WHE World Housing Encyclopedia document. So you just see the structure has totally failed. There is no lateral ties. The longitudinal bars has been bended, buckled, failed, and spalling of the concrete also. And comes to the beam column joint. We have discussed till now about the beams, what are the provisions given, how we have to incorporate. In the columns, what are the provisions we have to think about. Now comes to the, so once we think about the beam and column, and we have confined the beam nearby the joint and column also nearby the joint. What will be the subsequent effect of the beam column joint? That will be the weaker link in the total system. So we have to consider and adopt methodology to accept the fact that that area also should be confined. So avoid shear failures. Adequate anchorage for reinforcement from flexural members has to be provided, and the confinement reinforcement, the joint should be same as in the columns. Whatever be the confinement reinforcement by prescribing for columns, that has to be extended throughout the joint also to avoid shear failure of the joint. Consider the confinement provided by the framing of the beam into the system. If we can give some relaxation for the spacing of the lateral ties, has to be think about, and design shear strength should be more than the demand at the joint region. Otherwise, that will lead to the failure of the joint region. So these are the provisions. You can see here, this is the new caudal provisions. In the previous versions, what I can say, the stirrups in the joint region was missing. Now we have developed, we have incorporated that also in the picture. This confinement length L0, vertically as well as horizontally to the beam as well as the column, should not be lesser than larger dimension of the column. Think about the beam column dimension, consider the larger dimension, and 1/6 of the column height and 450 mm. This is the joint, and the column has to be confined top and bottom vertically up and down. And what should be the minimum length L0 should be the larger of these three things. That thereby we are confining this concrete area. Binu, is there any limitation for timing?
You can go up to 12 o'clock. We have the assigned time.
Yeah.
So you can go up to 11:30. Then we have a discussion.
Okay. So I'll take some more time.
Yeah.
So special confinement reinforcement, what should be the spacing of the links? Should not be more than the smallest, because in here also we are telling that for end lot length, top and bottom of the joint region, we should provide lateral ties. What should be the spacing of the lateral ties? It should not, we have to adopt the smallest among these three, 1/4 of the minimum member dimension of the column or the beam, and 6 times the diameter of the smallest reinforcement bar, and 100 mm. So see, whenever it should not be less than 75 mm, also we have described. See, in so many cases, if the youngsters are asking questions like, why you adopted 1/4 of minimum dimension? Why 6 times diameter? Why not 4 times the diameter of the bar? At present, technically, we can say that from the past experience, from the experimental investigation results, we have come out with these provisions and these solutions. But kindly follow that. And we were talking about what will be the lateral ties and how much should be the spacing. And if we are providing the dimension of one leg is more than 300 mm, there we have to provide cross ties. All those things we are discussing like this. And what will happen? What should be the minimum area of steel required in case of circular columns? The shear reinforced shear bar, maximum of these two things we have to calculate. In this case, dk is nothing but the diameter of the core of the outer edge of the link. When we look at this, what I can say, this dimension, this dk will be the outer edge of this diameter of the bars, and AK, when we are thinking about area of confinement, will be within this link, outer to outer of the link. That's what it's mentioning. So this for circular column DK, and it is again function of gross cross section and confined area, and in rectangular section is directly proportional to the HH is nothing but the larger dimension of the link, the horizontal link. It should not be more than 300 mm. If it is more than 300 mm, we have to cut that length by introducing a cross tie. Then the what I can say, the unsupported length has to be considered as H. What is the effect of distortional shear? When you look at the beam column joint, these are the force components in the beam column joint. If the shear is acting and top and bottom like this, and this core region, you can see here, this core region will be subjected to a severe shear. This is the compression zone, this is the tension zone. You can see this diagonal will be subject to tension, this diagonal will be subject to tension. The tensile stresses will be taken care by the reinforcement, and the compressive stresses has to be taken care by the concrete area, and it will lead to the failure of the concrete joint, and finally left out with the failed conditions like this. This is also the external joint region. To avoid this type of joint failure, we should consider the shear capacity of the joint should be more than the demand, shear demand at the particular joint. For that, there are a lot of provisions given in the code. If the joint is confined by beam on all four sides, like this, means this is a joint, the beams are coming from all the four sides. In such case, the nominal shear capacity, strength capacity should be to JC has been calculated by this expression. This AEJ is nothing but the effective shear area of the joint. Vj into Wj. The clear explanation is there given in the code IS13923, 13920 clause 9.1. And if the joint is confined by beams from all the three sides, there are some reduction in the capacity as 1.2, because when we have beams from all the four sides, that will give more confinement to the system. That confinement reduction is there if you are missing one beam from one side. That's why from coefficient has been reduced from 1.5 to 1.2. Now look at to the third point. Is the external joint beam column connection. This is the corner joint connection. In the corner joint, what is missing? There one more beam is missing. There also the factories like that is going on. This is the capacity of the joint is calculated. Now comes to the demand. What is the demand? For shaking along x direction. So when the beam column joint is subjected to a shaking in x direction, there is a expression given. It is nothing but the shear force coming on the joint in x direction, and this is the area of the effective area of the joint region for shaking. This is y direction. Sorry, this small mistake is there. This is y direction. And then the demand has to be calculated. This is the demand. And always, as a summary, we can say that the capacity should be always more than the demand. This is the expression tau CJC, which you are calculating using this expression should be always more than the demand coming on that particular time. This is the summary of demand and what you can say capacity of the joint region. So in order to satisfy that particular demand on as well as improving the capacity of the joint, we should provide closely spaced stirrups throughout the joint region also. This is a closely spaced stirrups. This is not 10 times, it is 6 times. This picture I taken earlier. And finally, you just see the beam column joint. Definitely, everyone, all practicing engineers are complaining that this area is becoming totally congested. We are unable to pass through the stirrups to this joint region. And I have given some idea to them before putting your beam reinforcement coming from this direction. You put these links down initially itself. Whenever you are putting this beam reinforcement from this direction, when you are arranging that, raise one by one and appropriately tie in appropriate locations. This is the provisions we have to suggest. The practicing people in the field, supervisors also will say that it will be too much difficult to provide this closely spaced stirrups in the joint region, but we have to tell them as an engineer, we should find a solution and tell them how we can incorporate that. Now comes to the shear walls. Shear walls. Always I used to ask my students while teaching whether the shear wall is failing under shear. Now my students are very well know the answer. They will say no. So this is I used to tell it's a misnomer, the shear walls. So this is the shear walls in the structure. You can see here. This always general feeling. This always protect the structure from lateral reinforcement, and it will definitely the shear walls will provide sufficient resistance towards the lateral load. We generally distribute the load as a gravity load will be taken care by the frame system, and shear wall will take care of the lateral loading system. The appropriate sharing is possible with this hybrid system. So what are the general provisions? Like minimum thickness should be 150 mm, and it should be 300 mm for buildings with a coupled shear walls. And minimum length to thickness ratio should be 4. Minimum thickness to length ratio. And there are classification of shear walls like squat, intermediate, and slender, depends upon the height to length ratio. So if the height to length ratio is less than 1, it is called as squat shear wall. It will not become ductile. So we should not adopt such type of shear walls. And intermediate, if the H/LW ratio lies between 1 and 2, it is called as intermediate. Slender shear walls will will be performing nicely. And this is the shear wall along the, this is a picture which I am showing, like along the periphery. So many, most of the time when we are analyzing the structure, some occasions we will get torsional mode, predominant torsional mode, that will leave out the structure to rotate abnormally, and the columns also will be subject to a lot of torsions. I always used to advise the structural designers, like, kindly avoid the occurrence of torsion in the system. We are not designing the columns to take care of the torsion. So better avoid that. How to avoid? We can place the shear wall in the periphery accordingly wherever we want. Thereby we can reduce the torsional mode in the structures. So the shear wall is a very good savior for our structures subjecting to lateral load. And what is happening? What is happening when the shear wall is subjected to lateral load? It will undergo the flexural cracks. So the mode of failure, definitely the mode of failure of the structural shear walls is always in flexural mode. It's not under the shear mode. So what will happen? This particular area will be under tension, and this particular area will be under compression. So we need to provide additional consideration for the boundaries. If we can provide boundary elements, if there is no need to provide boundary elements, we can confine the boundary area with closely spaced structures like that, and always make sure that the shear wall is not it should not be a curtain wall. The shear wall should continue till the foundation. Always the RC shear walls, whatever we are talking about, the shear wall should start from the foundation. Then only we can call the shear wall a shear wall. It's not like a, what you can say, it's a curtain wall. It will not give appropriate results. It will not perform. So if we need to provide boundary elements, then we have to appropriately consider the boundary walls like this. And what is the minimum reinforcement in shear wall also given? This is in the table 1 of IS13920. What shear wall, what should be the minimum reinforcement, rho V minimum and rho V net minimum. All these things have been, but in order to get an appropriate, what I can say, ductility as well the performance of the shear wall, we have to satisfy the minimum steel requirement. This is just a picture I am showing the construction practices of the shear wall, and this is nothing but the coupled shear wall. And see, I always used to feel that the shear wall is not made out of concrete, it's made out of steel and covered with concrete. This will be the reinforcement requirement for a structural shear wall. So now comes to this is the provisions I have almost covered. What are the provisions? What is the consequence of provisions for the beams, columns, joints, and shear walls? I think I almost covered what are the provisions of IS13920. But I want to get your attention towards what is happening in the practice in the site. It's a warning for all the youngsters who are going to become the future pillars of Mother India. So just see what are the wrong practices in the field. Look at this. What is this? I myself could not understand. This is a beam column joint. We are talking about closely spaced struts. Anchorage length should be gone from the top bars, should be anchored down, and bottom bars should be anchored upward. All those things we are providing in the code. But who is practicing? Just look at this particular point is a failed system. There is nothing, no reinforcement. It's almost behaving like a plain concrete at the joint region. Who can protect it? Even God cannot protect such type of structures. Now look at this. See, we are talking a lot of things. We just see the hook dimension. Even 90 degrees is not there. The hook is not even bended with 90 degree, or after failure it would have been opened up. And this one, you just see this is a lateral space, lateral ties with spacing of lateral ties. Just see how can it confine the concrete within this area, or how can it can bundle this longitudinal reinforcement. This has to be who is responsible for all those things. And just look at this. This is the reinforcement detailing at the site. Why it is like that? We have to find an answer for all these things. But I don't think it is not only of ignorance. We know, we very much know. And who is playing this? I cannot have any words to comment wrongly on anyone, but we, we the engineers, the youngsters, we should practice the ethics that has taken out to practice ethics in our profession. I wish all the best wishes to the youngsters for a bright future. And hereby I should acknowledge Professor A.S. Zaria, starting from Arya, he is no more now, and Professor Jain and Sivya Murthy for being the pioneers in introducing this field of study to the civil engineers. Earlier, earthquake is only within the seismologists. Now, these people, these eminent people have brought this area of study to the civil engineering, the field of civil engineering. And a very special thanks to Professor C.V.R. Rupan and Vijay Narayanan and Vipin Mehta for developing this such a nice document, earthquake behavior of building some concept. They have prepared for the Gujarat State Disaster Management Authority. There are very, very clear and understandable way of presentation of the matters related to earthquake engineering. And I am so proud to say that A.R. Vijay Narayanan is my own student for the UG program, PG as well as PhD. He completed with Professor. Thank you, and thank you all. Thank you for patient listening.
Thank you, Professor Jaya. Thank you, Professor Jaya, for the highly informative lecture. Thank you all the participants, those who are attending the session through YouTube, live streaming and through Zoom platform. Now the participants are requested to post your questions in the question answer chat box. We will try to post maximum questions in Zoom and will be answered. So it is open for discussion now. So you can post your questions in the question answer session. Thank you.
I've seen some questions here.
Yeah, very lengthy question.
Thank you, ma'am, for the detailed presentation on seismic requirement of structures. I have the following questions. One is welded splicing is advisable as welding makes the steel brittle and reduce the tensile strength. See, that provision is given. It's brittle means that this is what I can say. Welding is happening for a very short length, and that will not impose much hazardous to the situation. And that's why, considering that aspect only, we have allowed the splicing with, in the present code, with welding also. Is the single circular tie in a cross section of circular columns enough for column for all dias, even for 1 meter dia also? I didn't get the question. Is a single circular tie in a cross section, is any additional diagonal or orthogonal directions are required? If we can confine, or we can, yes, I understood the question, like you want any additional cross tie sort of thing which we are providing in the rectangular. If we can provide diagonally, it may, not diagonally, radially. So that will give additional, but with the support of the longitudinal bars, this 1 meter dia circular cross tie without cross tie also it can survive. It's, what is the definition of coupled shear wall? Coupled shear wall is the two shear walls side by side, or I can say very specifically, like in a shear wall, if you are providing opening, and that will also be called as coupled shear wall, and these two shear walls nearby will be coupled through beams. That is what is called the coupled shear wall. What is the closest spacing between shear walls, end to end, to define it as a coupled shear wall? Closest spacing between shear walls, end to end, to define it as a coupled. Even the specific opening, the 3 feet door opening is also will be sufficient to call as a coupled shear wall. I think I answered for that. The next question, respected ma'am, thank you for the presentation. Can the shear wall be provided for composite structures? Composite structures with what? Whether that material has to be defined composite means it's a composite steel and concrete. No problem, we can provide shear wall. Which material has to be? So whether you are thinking about composite wall with steel concrete shear wall as with steel decking, or concrete steel shear wall with concrete decking, either is possible. Composite structure can be used with the shear wall. Please explain about spring inserts in case of infill walls. Spring inserts in the case of infill walls under seismic load. Spring inserts in between the in between area. Spring inserts in the case of infill walls and that will not. What I can say, I always prefer solid walls in case of resisting lateral ties. Not infill. Spring inserts in the case of infill walls. Next question, ma'am, will high strength reinforcement bars and pre-stressed bars have an influence in terms of ductility when it comes to earthquake resistant structures? Yes, high strength reinforcement has less ductility, so that will not provide good performance during earthquake. And pre-stressed bar, definitely the hysteretic loop with the pre-stressing structures is very, very narrow. That will not dissipate much forces, energy. So it is not that good in case of earthquake resistant structures. Why the Indian code recommends open joint detailing in column foundation joint, whereas other standard offer closed joint detailing practice. Open joint detailing in column foundation joint. So we are working on further detailing part now, but as of now, we are designing the foundation as the strongest, column is the next, and we are providing sufficient detailing at the joint region between the column and foundation. If we will look into this matter later. Why the Indian code recommends often? Wonderful. And, okay. Why we are not using welded in lapping of things? We are suggested for welding of this, right? We are suggesting for welding also in the present code. It's okay. IS1893 2016. That is for 15 meter, we can't use the equivalent static method even in zone 2. Should we prefer that method for analysis? It's our request for you. We will light into that. See, better we will go with the dynamic analysis for even for seismic zone 2. If we are going with 15 meter height, means 5-story building, it's above more than 5-story building, better to go for proper analysis and do the design. Analysis, doing a design analysis is much required element in putting the design. Better we will go for that. And in which direction we have to provide the shear wall? Is there any relation between base isolation technique and shear wall? So the which direction? It's a very good question. So in order to avoid torsion, we should distribute the shear wall in both the directions. It's very much important to register that the stiffness from both the directions should be same. Then only we can maintain the torsion in the system. So we cannot provide shear wall in one direction and expecting that the earthquake will happen only in that direction. That's not possible. We have to provide appropriately place the shear wall in both the directions to maintain the stiffness in both the directions. And the relation between base isolation technique and shear wall. Base isolation technique and shear wall is it's not matching together. This base isolation means we are isolating the structure. We are isolating the structure from the base. The shear wall, it is resisting the forces in the direction. When will the column be subject to torsional loading? Because when the building is subjected to torsion, the columns will be subjected to lateral forces, not torsion, right? Yes, of course, the column will be subjected to lateral force if the total building is subjected to torsional move. Where the torsion will go, that also will be imparting some level of torsion into the structure. So better that when will the column see, when the center of mass is not coinciding with the center of stiffness, definitely there will be an occurrence of the torsion. At that time, the overall structure is subjected to torsion. Then how can we avoid? So better we should avoid the torsion in the system. Minimum thickness of shear wall now revised 160 as per the resolution. The same should be reflected currently. Okay, we will look into that matter. What is the minimum reinforcement rectangular column as per the ductile detailing code? Minimum reinforcement of the requirement is we should follow the minimum requirement. See, basically IS456 is the basic fundamental code for the design. This 13920 is giving you the provision for additional detailing for the confinement of the concrete. I always used to suggest my students that whenever you are writing the any document, kindly mention that design as per IS456 and detailing as per 13920. Better you go with the provisions given in the IS456. Two shear walls of 1.5 meter longitudinal dimension, each spaced at 4 meter connected with beam. Will it be a couple shear? Is there any guidelines to decide? So the spacing between the what I can say two shear walls should be limited. So I'll suggest like it should be limited as the width of at least one of the shear wall. What will happen means the coupling beam will have to be designed as a huge element and provide a diagonal reinforcement in the system. Better we will identify and fix as the spacing between the two shear walls be limited to the width of one shear wall. So for simply supported beam, you should follow ductile detailing. Simply supported beam, we are getting the maximum moment as the sagging moment at the midspan of the beam. The ductile detailing, see what will happen to the simply supported beam when it is subjected to lateral load. Think about that, it will not undergo a double curvature effect. Whenever it's any element comes to double curvature effect, only we have to think about the what I can say tactile detailing provision. It's a good question. I enjoyed this question. So there also we should maintain and adopt whatever be the required reinforcement as per the design provisions. Minimum thickness requirement of coupled wall structure is whereas for the regular wall. So to activate this clause, clear definition of coupled shear wall is also required. Fine, we will give the clear definition in the code. Thank you. Ma'am, is there any standard for ductility of pre-stressed concrete? The pre-stressed concrete element itself is not a ductile element. Then how can we maintain a standard for the ductility provisions for pre-stressed? See, when you look at you just look at the historical pre-stressed concrete number, it's very, very narrow. It is not at all dissipating any energy. It cannot be deformed much also. It will not go to the inelastic range of deformation. That is the difficulty with us. Is there any procedure for getting best economic distribution of shear wall in plant? That both depends upon, see, I'll say that it's a question of chick or egg first. So the first and most important factor is we should avoid torsion in the system. In the torsion in the system, if we can arrange the beam as well as columns appropriately is more than sufficient. Then if you are incorporating shear wall into the system, make sure that the shear wall is arranged along both the direction, which will give a non-torsional performance of the structure. That will be the more economical and better perform the shear wall distribution system. how the member stiffness is compromised while making a main. So, okay, member stiffness is compromised. We are not compromising the stiffness requirement of the system. When you look at the stress strain curve or low deflection deformation, the initial stiffness of the system up to the yield level we are maintaining the same. So beyond that, the stiffness that what I can say, stiffness is more what load versus the ratio between load to deformation. The initial stiffness, we are not at all compromising with anything else. We are making that structure as a ductile one, giving more deformation without losing the strength only. The stiffness, we are not at all compromising by making as a ductile one. It's a wrong concept and a wrong understanding. Thank you. Is minimum tensile steel requirement applied to top steel of simply supported? Minimum tensile steel requirement applied to top simply supported beam. So definitely we have to provide the minimum hanging bars at the system, and we have to check whether that is sufficient or not. That minimum is to be maintained. Is the lightweight concrete structures be made ductile by providing shear wall? Generally, lightweight concrete will not be using as a structural concrete for constructing structures which has to be resist especially lateral load as well as the gravity. Lightweight concrete is generally not using. It may be using as only as a partition walls. Based on column shear wall, we identify the location of lateral load resisting pattern, and for that column, the beam only shall be follow ductile detailing. Based on column shear wall, we identify the location of lateral load resisting pattern. I couldn't understand that question. So, what do you want to say that you have to detail the column only as a ductile, and we should leave the shear wall without ductile detailing? See, when we are incorporating two elements into a single unit, we have to maintain, we have to follow the ductile detailing pattern for both the structural elements. I think I answered almost all the questions now.
Yes, I hope so.
Yeah.
I think, yeah, a few more questions are there. I think
in column is coming again. So in column confinement, open links are provided to inner. In the column confinement zone, the open links are provided for the inner longitudinal bars accounted in the shear calculation. So closed links to be accounted. Here, the area of reinforcement for ties should be. We always used to calculate what I can say link. So whatever be the cross section, what is the cross section offered by the shear reinforcement, 2 leg, 3 leg, 4 leg, that all legs has to be incorporated in the calculation of the shear area of the reinforcement. How to distribute shear wall in plan effectively to avoid torsion. That's what I told you. You have to calculate the center of stiffness as well as center of mass and appropriately arrange the location of the shear wall in order to match the center of stiffness with that of the center of mass. Thereby, you can avoid occurrence of the torsion. The IS code says for floating column is allowed if it is not a part of primary lateral loading system. Now, my doubt is whether we can rest RCC wall on transfer corridor. This is a very good question. Actually, when you look into the only concrete wall constructions, just imagine now people are calling with a new terminology like Maivan wall. When the total structure is constructed out of this Maivan wall or concrete wall, and sometimes that wall cannot be extended through the ground floor, because in the ground floor we may be in need of openness to accommodate the parking of vehicles. At that stage, this wall is resting on a transition girder. that has to be designed as a deep beam. The deep beam should be rest on the wider columns. In that case, we may have to accommodate. So in that case, the primary load resisting system is not the shear wall. The primary load resisting system is the bottom columns. When you are looking at the bottom, what I can say, open ground story, that will give left out as a stage of open ground story. 13920 is silent on deep beams as well as the transition girder and what I can say, floating column is permitting, but make sure that the floating column is not imparting dangerous to the system. It has to be properly designed. The floating column and the supporting transition girder has to be designed. Thank you. 13920 speaks only about special shear wall. Is the RC structural wall covered in the code, or which standard should IS456 is speaking about shear walls also. Based on the column shear wall, we identify the location of the lateral loading position and for columns only shall be followed. No, it has to be followed both. That's what I mentioned. I think I covered. Madam,
Thank you so much, Professor Jaya. You have answered all the questions.
Yeah.
Our principal has joined.
Yeah, thank you so much.
Jaya, can you just stop sharing the presentation now?
Yeah, 1 minute. Okay, thank you.
Our principal has joined. Sir, welcome.
Good morning, madam.
Good morning, sir.
Thank you, madam. Thanks for accepting our invitation, madam.
Thank you.
Great, very nice presentation, madam. I have seen in the YouTube live streaming also, there were so many positive feedback about your presentation. So thanks for accepting our invitation. Thank you, madam. On behalf of our management and all of us, I would like to convey our very sincere thanks to you, madam.
Thank you, sir. Thank you so much.
For the benefit of all the faculty members across the country. Thank you, madam.
Thank you for inviting me.
Thank you.
Thank you, Principal, sir.
Thank you, HOD madam, civil madam, for organizing such a very nice event, madam.
Yeah, okay.
Identifying eminent resource persons like our Director Research from Anna University. Thanks for all the faculty members. Very great effort. Thank you, madam.
Okay, sir.
Thank you, all the participants. Thank you.
Thank you, sir. And we have 2 more sessions tomorrow and day after tomorrow. Tomorrow, Dr. Rekukant sir will be talking on earthquake hazard assessments. And on that Saturday, Dr. Satish Kumar will be talking on the impact seismic code provisions on seismic design of steel buildings. And all the participants, please fill the feedback and as well as the assessment forms. It will be posted in your Facebook and Twitter pages, as well as it will be sent to your mail IDs. So thank you for the patient listening. And we have 2 more wonderful sessions. So thank you so much. Thank you all the eminent speakers, Jaya ma'am, Murthy sir, Rekukant sir, Satish Kumar sir, and Ruben sir for your presence over here. So thank you so much.
Thank you, Bino.
Okay, we'll see you on another 2 more days, tomorrow and day after.
Madam Ishwaran.